Find the Fourier series for the following function. Here is the function, and the period is 2. So L is the half of Fourier, which is half of 2 is 1. And we know that the Fourier series is given by this formula where AMs, M0, 1, 2, 3, 4, etc. and BMs are found by this formula. So let's find A naught first. So now A naught is 1 over L, which is 1 in our case, 1 over 1, negative L to L, so negative 1 to 1, the function fx, which has 2 pieces by the way, and cosine 0. For A naught, cosine 0 will be 1, so fx dx. Okay, 1 over 1 is 1, so don't have to write anything. This function is given by 2 pieces, so negative 1 to 1 should be written negative 1 to 0, where the function is x plus 1 dx, plus 0 to 1, where the function is 1 minus x. Okay, now we do the algebra, this calculus 1, and get the value of A naught. Then with this calculus 1 work, we get A naught to be 1. Okay, next we find AMs for M 1, 2, 3, 4, etc. And this is 1 over L, so 1 over 1, negative 1 to 0, the function, sorry, negative 1 to 1, the function, and cosine m pi x over 1, just m pi x dx. Since the function was given by 2 pieces, so we need to break this down into 2 parts, negative 1 to 0 and 0 to 1. Okay, so that's negative 1 to 0. In that case, the function is given by x plus 1 cosine m pi x plus 0 to 1. This function is 1 minus x cosine m pi x dx. Okay, now we can use integration, we can do the integration by parts. This is u and the remaining is dv. Same thing here, u dv. But if you distribute x in 1 and negative x and use the properties of even and odd functions, you can get the integration in more efficient way. Okay, so now you have a couple of choices. Let's do the integration by parts. So this is u remaining dv. For the second integral, u dv, and using the integration by parts is uv minus v du. Same thing here. Now we plug in upper limit, lower limit. Sine 0 is 0, and sine when x is negative 1, negative m pi. This negative can be pulled outside. Sine m pi, m is an integer, and sine integer pi is 0, so this whole thing is 0. Okay, or we could have said negative 1 plus 1, 0. Same thing here, this whole thing is 0. Okay, now we have these two integrals. Let's find that. Okay, then when we evaluate, antiderivative of sine is negative cosine divided by m pi. Same thing here. Now negative times negative positive, and m square pi square outside. Upper limit cosine 0, that's 1, minus lower limit when we plug in negative. Cosine of negative angle is same as cosine of positive angle, so cosine m pi, that is negative 1 to the m. Okay, cosine of integer pi is negative 1 to that integer. Okay, and same thing here. Now we combine these two numbers, so we in fact we can factor everything. So 1 over m square pi square, 1 over m square pi square, that leaves 1 minus negative 1 to the m minus negative 1 to the m minus minus plus 1. So 1 1 2, and these are same, so 2 copies. So 1 over m square pi square 2 minus 2 copies of -1 to the m. Now -1 to the m is -1, +1, -1, +1. So when this is +1, 2 times positive 1 is 2, 2 minus 2 is 0. So when m is odd, that happens, this becomes +1 when m is an even. So when m is an odd function, this becomes -1. -1 times -2 is +2 to 4. So this will be 4 over m square pi square. That's when m is odd. Now we can do better than that. When m is odd, we can write 2m minus 1. So this is same as 4 over 2m minus 1 squared pi squared. Now we can say m is 1, 2, 3, 4, etc. In the same way, we find bm's. And next, bm's are given by the following formula. Okay, the formula for bm is 1 over L, and this, where L is 1 in our case, and this function has 2 pieces. So for -1 to 0, this function is x plus 1, and this is 1 minus x on 0 to 1. Now we can do the integration by parts, similar to the previous step, or you can distribute x 1, 1, -x, and use the properties of even odd functions. But at the end of the day, this is 0 for all m, 1, 2, 3, 4, etc. Now we want to write down the Fourier series for the function. So the function is a0 over 2, okay, plus sum m from 1 through infinity am cosine m pi x over L plus bm's. All bm's are 0, so we don't have to write anything. And this is 1, okay, so 1 over 2, okay, a0 was found 1 earlier, plus this is m from 1 through infinity. Look at am's are good for m odd, and we found that to be 4 over m is square. No, that's m was odd, so we change that to 2m minus 1 square pi square cosine m pi x over L. L is 1, but m is just odd, so we have to go for the same thing like 2m minus 1. So this is 2m minus 1 x.